Welcome to yet another GPAP webinar session, the 30th GPAP webinar, which will focus on become a software engineer from beginner to job ready. Yeah, so before we dive into today's webinar, I will give a brief presentation of what the GPAP program is all about. And this will take about 5 to 10 minutes of your time so that I'm able to go through this presentation and you get familiar with the GPAP program. So what is GPAP? GPAP in full is the Graduate Professionals Apprenticeship Program. About the GPAP program, so it's a reskilling program providing hands-on experience. And why the GPAP program? It's aiming at offering experience, knowledge, and skills gap so that professionals can access work. So who does this program target? It targets graduates, career changers, vacancies, university students. And when does this program happen? This program happens on a monthly basis. Every month, the program is happening. And where does this program happen? At Tech Bus Hub, which is located in Ntinda, here in Kampala district. And how does this program happen? It's a full-time on-job shadowing, which is experiential in nature. So the duration of the program, so it's aiming at offering 2 years of experience in 3 months. So in the 3 months in the program, we're actually getting 2 years of experience. Yes. So, and it's ideal for job readiness, for who are looking at becoming job ready, for navigating workplace hierarchy. You're looking at moving from an officer to becoming a manager. Maybe you've been stuck in an officer role for like 5 years and you want to accelerate or leapfrog to a manager or a coordinator. So this program is ideal for you. Then the purpose of this program is to build a successful professional career through mentorship, coaching, exposure, and connections. And the capacity of this program, it is limited to 5 people per cohort. So the maximum people we receive on a monthly basis is 5. And the story of GPAP, it began in 2017, and it has had about 130 alumni from 12 cohorts. And its performance is 96% completion rate. What do we mean here? At least 96 of our participants complete the program from start to finish. Then the impact story, 87% influence participants' journey. Yes. And then advanced strategy for industry, academia, bridge. So we have a case study here that was done by Tech Bus Hub. And in a space of 10 years, Uganda releases about 4 million graduates. And the number of jobs available in these 10 years is about 700,000 jobs, which shows that the unemployment gap is quite wide, given that the jobs available are not enough for the 4 million graduates that are released out 10 years, each 10 years. Yes, so which is a very worrying figure, because if unemployment of about 3,300,000 graduates, it's a very alarming figure. And our research is backed up by proof. It's not something that is forged, but it is backed up by proof, because as you can see, the Nile Post is talking about the job crisis, the Daily Monitor talking about the unemployment crisis, the Guardian talking about Uganda's unemployed graduates held back by skills gap. So now that we've understood the problem happening to the young professionals out there, why should someone join the GPAP program? To gain employable skills. So with the GPAP program, there is mentorship. Participants acquire highly demanded and competitive skills set in the job market. Then then you're able to acquire valuable work experience, because there is coaching and support. Then there's also room for networking opportunities. So you get exposure and you connect with like-minded individuals and professionals in your industry. Then personal growth. There's competitiveness. You develop essential soft skills such as communication, teamwork, and problem solving that will benefit your career. Then there's also fast-track employment. So your chances of getting hired once you've been on the program are quite high. Then we have testimonials from some of the participants of this program. We have Alinda Rutaraka, who shares that he didn't know how to market content, and after creating it, but through the program, he learned how to strategize his content, plan his tasks, optimize it for the SEO, and distribute it through various channels. Then we also have Best Fusinje, who says she learned so much through the program. She wasn't familiar with accounting softwares like QuickBooks, but now through the program, she knows how to post receipts and expenses, generate finances, reports, and beyond technical skills, her confidence has really, really improved. Yeah. Then we also have testimonials or feedback from people who have been able to go to our YouTube and be in position to watch our mentorship sessions. And here we have Baroda Marvin saying that GPAP YouTube mentorship sessions reminded me that becoming employable is not just about technical skills, but rather becoming a person employers and clients can trust. Then we also have Eric Jane, who says they have followed your mentorship sessions and found them insightful, especially on practical skills like content strategizing and data-driven decision-making. This has shaped his approach on content creation. So these are some of our alumni. We have Bess Pusinje, we have Alinda, we have Grace, we have Sylvia, Julius, Celine, Rose, and many other alumni who have been on the program. So who is GPAP's best fit? So we have students who aim at gaining valuable work experience. We have graduates to bridge the gap between academia. And then we also have career development to acquire role-based training and onboarding to advance their career. The different departments on this program, we have the human resource department, we have the research and projects department, we have the multimedia department, we have the proposal writing department, we have the accounting and finance, the digital marketing, the sales and marketing department, software engineering department. So if you're out there and you're looking for skills in any of these departments, the GPAP program is the best place you can find the skills you're looking for. These are some of our posters. These are about your focus, GPAP focuses in your career. So in case you land on this poster, you can share it, repost it, so that a lot of people can get to know what the GPAP program offers and how they can benefit from this program. So what wise men say? Tell me I forget, teach me I may remember, involve me and I learn. So Benjamin Franklin says that. So GPAP provides hands-on experience, making learning effective and lasting. Then apprenticeship programs is the most natural way of learning. It allows skills to be passed down while fostering discipline, humility, and mastery. Yes, so then also finally, that is by Robert Greene. Then lastly is the best education does not always happen in a classroom. Apprenticeships empower people to learn by doing, ensuring that knowledge is lived, not just memorized. That's by Malcolm Gladwell. So we also have discounts and freebies, whereby when you recommend someone for the GPAP program, there's a 10% discount. And also for these particular webinars, like the one you are part of, they are free of charge. So in summary, GPAP is a hands-on skilling program, providing 2 years of experience in 3 months to graduates, career changers, holiday makers to leapfrog their career to excellency with mentorship, watching exposure, connections, and competitiveness to get jobs faster. So what do we mean by leapfrog your career to excellence? To achieve rapid non-linear professional advancement by intentionally bypassing traditional slow step-by-step promotional paths to reach high-level positions faster instead of linear trajectory. So join GPAP today. GPAP offers employable skills, work experience, and career fast tracking. Yes, so we have a few slots available. Join us today to start your professional journey. If you want to apply, techbuzzhub.org/jobs. In case you want to contact us for more information, the contacts are available there on your screen. So you can as well visit our website, which is www.techbuzzhub.org/GPAP. So that is the end of my presentation, and I welcome the software engineering team to go ahead and share their knowledge about becoming a software from beginner to job ready. Over to you, software team.
Hello everyone, and my name is Mambo Emmanuel Taban. Yeah, so we shall be taking you through software engineering. So, I don't know how many of you have known software engineering or are new into this field. So what we're going to do is it's made in a way that at least each and everyone will be able to go out with something on software engineering. So let's look at software engineering. Software engineering is a systematic discipline and quantifiable approach to the development, operation, and maintenance of softwares. So in 1960s, that's when software engineering was born. This is due to a software crisis and widespread of budget overruns and poor quality products during that time. We say that it's a discipline of applying software engineering principle to design, develop, test, and deploy, and also do maintenance of software systems. It follows a structured approach to ensure that the software is reliable, efficient, and secure, as well as scalable, while meeting the user and business requirements. You'll find that when a software is being developed, it's it should be scalable. In case the users increase, the number of users increase, it should be able to do that. It should be able to withstand the number, and then let it also be secure, because nowadays most softwares, they have security issues. So when you're developing this software, so that it's also what? Secure. Let's look at the software product, what a software product is and what a software program is. Now, we said a program is an executable code that performs a specific task. Like when it's a block of code that performs a specific task. And a software product, it extends to the documentation, the licensing, and also support, making it a more complete deliverable solution to a specific problem of a business or a company. Let's dive into some of the languages that we normally use in software engineering. Here there might be few, but there are a number of them. One, we have the JavaScript, we have HTML, we have CSS, we have Python, we have C++, we have C#, and some of the IDEs, they include the Eclipse, we have PyCharm, we have VS Code, that's the Visual Studio Code. So of which I'll be breaking it down in a later slide. So let's look at some of the common databases that also we use. We have MySQL, which is there. We have Mongo databases. It depends on what you're building or what your system needs. Because like sometimes some systems might need MySQL, others might need Mongo database, among others, because we have a number of databases that are there. So we said modern applications, they rely on a purpose-built databases for performance, scalability, and also data integrity. Now, let's dive into the popular IDEs that we have in software engineering. As I said earlier on, when you're choosing an IDE, it depends on what your project is, what your project wants, or what are the requirements of your project. So sometimes, like most programmers, they use Visual Studio Code because it is light and it's extendable, and also it has a marketplace where we can be able to get some of the extensions that we may need in our project. And we also have Eclipse. It's open source. It has modular plugins, systems, and also the legacy enterprise use of it, which also makes it a good IDE. We also have the IDE market. You can choose the right IDE to boost your productivity and your code quality. Now, let's go to some of the engineering roles. We had a number, people said they are software engineers, others they are this. So what are the roles that we have in software engineering? One, we have the developers. So when we talk of the developers, we include people like the front end engineers, we have the back end engineers, we have the full stack developers, which are also there. And then in the operation, we have the DevOps, we have the security, we have also the cloud engineers, we have the architects, they are there. And coming to some of the most amazing part is the UX. Also, we have the UX designers, we have the quality assurance engineers, we have the web engineers. So these ones ensure that at least your user interface meets the requirements, the user requirements. And the other section we have is the management. We have the product owners, we have the scrum masters, we have the project managers in that. As you can see on the screen, we have software engineering. We have the front-end engineers, quality assurance engineers, full stack. We have machine learning. We have software architects. We have uh, requirement engineers who deal with collecting some of the requirements that are needed during the production. So if you're into that, you can pick any role from those roles, any that is suitable with you. When you're good at graphics and so on, you can join the user interface career. If you're good at coding, you can join maybe the back end or front end. So it depends on what you're good at. Let's look at the project management. So project management, these are people who ensure that the product is delivered and it meets the client's expectations. So when during software development, you'll find that there are tools that people use to ensure that they're able to deliver the product. Uh, Let me start with Jira. It's one of the tools. So it has, we have the backlogs, we have sprints and Kanban boards. So these ones here, when you talk of the backlogs, it's a section where you're able to communicate with your colleagues to see the progress and also to report some of the things. We have Slack. It's also it's good for business workflows and team messaging. You can message your team member. You'll be like, "Hey, are you done with this part? Are you done with this?" We have the Trello. It's good for visual boards and also conference weeks. And we have Mira. It's a collaborative whiteboarding and diagram. So you'll find that in Mira, you can be able to include maybe some of the designs, like some of the designs from Figma and so on. You can be able to display them because it has those sections. You can put stickers here and there to track also the progress. So let's look at the software engineering journey. So when you're starting to develop a software, we follow a methodology. You have to pick one methodology because there are a number of methodologies that are used. We said a methodology is a formalized uh, systematic set of rules, principles, and procedures that govern how a project is organized from inception to the delivery of that software. So one of the methodology that we mostly use is the agile. It's a specific methodology that is characterized by interactive incremental approach where each and everyone is given a task and you have to deliver. Like the project is divided into sections and done at once. So it's very easy and quick if you want to deliver your product quickly. So it's a bit faster compared to others. We have other methodologies. We have the water flow methodology. Now, looking at that, we have what we call the tech debit. So you'll find that here, the in here, what you do is that when you fix a bug, it's a temporary kind of a thing, but it is a bit risky. So the interest we pay on a code when we choose a quick temporary fix now rather than a perfect sustainable solution is what we call the what? The tech debit. Now let's go to what we call the code review. Code review, this is where the team members come and check the code. They check whether there is bugs or they check the style and the logic that is used behind that code before it is integrated into the main system.
Thank you so much, Emmanuel, for taking us through that. I'll be taking us through the software development cycle. Now, the software development cycle is a set of rules and principles that govern how a project is going to be organized from its inception to its delivery. And this helps us with a structured framework that ensures that software is built in a very efficient, high quality manner as well. So the first step of the cycle is the planning. In this step, we have to basically define and write down all of the requirements needed to fulfill this specific project. So we define the resources we're going to be using, and we need to come up with a roadmap. For example, setting deadlines and security requirements for a new app that we're making. The second step in the cycle is to gather all of the information. This is the analysis step. So now from here is where we start gathering our requirements. After listing them down, we gather them all together. And after we've gathered them, we go to the design step. So this is where we make our blueprints for how we want to use the requirements we've just gathered. So this is where our architecture comes in, building the structures, the user interface layouts and all. After we're done with that, we move on to implementation. So since we've already gotten the blueprints written down and all of user requirements, now is when we actually start writing the code and ensuring that it meets the standards of our blueprints. After we've implemented, we will test our code. We have to make sure that there are no components of the code that clash with each other, defects, bugs, and we also have to make sure that the code we've written and the final output matches what our client has requested of us. After we're done testing, that's when we finally are able to deploy. Once we've deployed our code, it's very important we have to keep track of it through our maintenance step. So from maintenance, we have to continuously deploy security patches and roll out the different updates and features as the software or the program scales. So to match it, that's what we do in the maintenance step. To go a bit more into our process as we're making it, we have a Scrum framework. So this Scrum framework helps us to carry out the different steps carry out individual steps that we're going to be doing for our project. So the first is the sprint planning. Sprints are basically time frames set to achieve a specific task required within our program or our project. So we have to plan, what are we going to do in this sprint? How long is it going to take? After we're done planning the sprints, we're going to be having daily stand-ups where people will update on how far they have gone with achieving what was required in the sprint. Then we would also be having sprint demos where people would be showcasing what they've been able to achieve And after they've demonstrated their retrospectives, where everyone comes in together, discusses what has been done, if it has been implemented well, or if it deserves some changes. But to go a bit more into software testing, it's a very crucial part of the software development process. This is the process of evaluating and verifying that a software project or application functions correctly, securely, and efficiently according to its specific requirements. So software testing has different types all coming in different times of the development process. So we have unit testing as a start. So this is where we test the individual components of, excuse me. Unit testing, we test the individual components of a software to ensure that they work on its own, these small parts. After breaking down the software into the smaller bits, we test to see if those bits can work just on their own. Then after unit testing, we move on to integration testing. Now we put all those bits together and test to see that all of them can coordinate together to fulfill the required function. After we've tested their integration, we now test the entire system, bringing all those bits together properly and testing the entire system from start to finish as a whole. When we're done with system testing, we move on to regression testing. So here we're just rerunning these existing tests to ensure that in case we added any updates or changes, nothing has been broken within our code. When we're done with regression testing, we can finally move on to user testing. This is where we give the program or the software to different users to get their feedback, see how they interact with the interface, and see if there's anything we can change to make their experience better. So within testing, there are two key terms that are always brought up. We have validation and verification. And we're always told to ask the question, for validation, are we building the right product? And for verification, are we building the product the right way? To go a bit more into it. For validation, where we ask, are we building the right product? Here we evaluate the software at the end of the development process, ensuring that it meets the user's needs and solves the problems. So that is at the end of production. But for verification, this is done as we build. We ensure that the software is conforming to its design specification and requirements as requested. I would like to conclude from here and hand over to my colleague, Derek, to continue the presentation.
Thank you, Martha. So DevOps is a short form for development operations, which is a collaborative professional movement that combines software development and IT operations to shorten the development lifecycle and deliver high-quality software consistently. The objective is to increase organizational velocity, enhance system reliability, and improve overall product quality throughout the implementation and the deployment of the product. Real-time production data is monitored and fed back into development to rapidly address bugs and performance issues. There's also automation, which eliminates manual repetitive tasks like configuration and testing to increase speed and reduce human error. So there's a CI/CD pipeline. CI/CD automates. These are automated pipelines that continuously integrate code and deploy validated updates, keeping software stable and release ready. After knowing the DevOps, you also need to know the version control. Version control systems are essential in DevOps, enabling seamless collaboration by tracking code changes and allowing developers to work on features simultaneously without conflicting. The They function as critical triggers for the CI/CD pipelines, where every commit automatically initiates the automated building, testing, and deployment processes required for reliable software delivery. So the core tools in the version control, we have Git and GitHub, where developers can share their code. You have Docker for containerization of the programs. Then the CI/CD pipelines and also the metrics for monitoring the data. So in conclusion, by combining structured life cycles, automated workflows, and version control, engineers create reliable systems that can adapt to changing environments requirements and scale over time.
All right. Thank you very much, Derek, Martha, and Emmanuel for making such an interesting presentation. At this juncture or at this point, we would want to listen in to some of the questions that you might have, whether you are a business person trying to build or managing a team that is building some software to ease how your business functions or solve a certain problem in your business process. And you're on this call, we are very, very happy to have you. Or if you are one of those trying to think about, pursuing a software career, I think this is a good session for you. If you have any questions for both Emmanuel, Martha, and Derek, feel free to unmute and you ask your question, or you can as well put it in the chat, and then our teams will be able to pick it up, and one of the presenters will definitely provide a response. Okay, there is a question in the chat, and the question is, maybe Derek can read the question.
So where ESA and NASA is asking what do we use to do the testing. To do the testing, we use another software that I think we didn't talk about. We use a software called Postman. Postman can be used to send requests to the platform, and then you check for the response from the platform, and then we figure out whether the response is right or the response is an error or a bug. So that's a nice question from Ethana. So Joel, I think Martha will answer your question.
Yes, Joel Kigo is asking, re-clarify the software engineering roles list. How exactly would you like us to re-clarify? Would you like us to be specific under which roles play, or could you specify a little bit? Oh, you're saying all. So for the software engineering roles, there are really, really many. And actually, not all of them require you to be a programmer and all. And they all fall under different categories and factions within the software development process. So, for example, for the user interface, what the user sees, the people that design that, we usually call them user interface engineers or developers. They're the ones who write the code in HTML, CSS, and they're the ones who basically beautify the work. Then moving on to the back end, an example of a role, the back-end developers. They use languages like Python, C#, JavaScript. All of these, they write the actual functionality of the different different parts of the code. So moving on now, those are front end and back end roles. Outside of that, even we have roles like machine learning engineer. These are the people who are able to build large language models. Another example of a role, we have the software architect. These are the people that actually design the way, the blueprint for how our code is going to work and how it's going to be built. We also have the project managers. Then they don't really need to know programming, but they need to have a good understanding of software engineering. They basically oversee the different projects that are being handled. If you'd like a proper list of all the roles, maybe I can share them with you in the chat that you can go through them yourself, because I could be here all day sharing them. Thank you.
All right, thank you very much, Martha. There is another question from Marvin. What do software engineers mean by better versions? That's a good question. And then there is another question from Aporo. What is the use of metrics in software engineering and how it applicable in the code? And then I think the last question is thanks for the submission on software roles. Okay.
Okay, thank you, Marvin, for that question. What do software engineers mean by better version? So when you're during the production, we have a number of versions that are being produced. So what we mean by better versions, these are versions that are yet to be released to the public. So most times they are near final production. So what they do is that they release that version, what you call the beta version, so that the engineers identify what loopholes are there in the system and what bugs are there, so that they can be able to fix the bug. So the major thing in this one is it's focused on fixing the bugs, and we have a number of versions. We have the alpha version, which is still early and unstable, and they are still working on it. And we have the beta version. We have what we call the release candidate, which is polished, but it has minor errors. And the last one is the production, which is a fully released software for that. Yeah.
All right. Thank you very much, Emmanuel. Musa, are you able to speak now?
Good afternoon, team. Thank you for your wonderful presentation from Martha, Derek, and Emma. It was nice hearing from you. And I would like to share my presentation about, I'm going to talk about websites. We all know that websites are so important in our daily life, as they help your businesses to grow, to advertise your businesses. Now here at TechBuzz Hub, we provide that opportunity by helping you develop websites, user-friendly websites that help your businesses to grow at a free cost.
All right. Thank you very much, Musa. And I think websites is another area that software engineers can pursue, since most Ugandans actually understand websites. And I think if you are an engineer or an engineer to be, it's very important that you also start exploring how to design websites. Because most businesses at least understand what sites are or websites are, as opposed to apps, and they are also easier, given that they are slightly simpler to get clients for them, and so on and so forth. So there is a last question that Martha was supposed to respond to, but then there is also another question from Robert. For someone who intends to start software engineering today, what is one language, programming language, or core concept do you recommend mastering before moving on to others in case it's development they are interested in? So Martha will respond to that, and then how best we could utilize the AI with software fundamentals in this stage. What's your advice on this? I think Emmanuel will also respond to that question.
The first question about metrics in software engineering. So code metrics, these are like measurements that are used to see how much a specific program or software can handle. Sort of like how mechanical engineers know how much stress like a pole can take before it breaks. So these code metrics are used, you calculate them with your code to find out how much can your program really handle. And there are different types of metrics: complexity metrics, size metrics, maintainability metrics, and so on and so forth. In a layman's term, that's basically what metrics are. Yeah.
All right. Thank you very much, Martha. Do you want to take the other question again that was asked? Which language would someone start with?
Personally, people always say it's best to start with Python because it's quite simple, it's direct, and it's easy to learn. So once you learn Python, you learn the basics of coding, you are able to move on, and learning other languages isn't as hard. So that's my suggestion.
I think let me start from where Martha left. Which language someone can start with. So when you're coming into software engineering, know that you're solving problems. And if you want to learn, the best I can say that is start with projects. When you get an idea, you're trying to solve a solution, you'll find that you will be learning a lot. Okay, I said, okay, let me start with the front end, and your system also needs back end. And from there, you'll be able to assess yourself. What am I good at, and which language is easy for me to understand? And from there, that's when you can now specialize. You'll be like, okay, since I've started maybe building maybe what a software that takes maybe notes and so on. So you'll find that by integrating a number of things, you're able to identify what you want to specialize in, because software engineering is a very broader kind of a thing. So it's better that you focus on a project, and you'll be able to realize what you're good at. And in the utilization of AI in software fundamentals, so AI has come to stay with us here. That is the fact. And recently we were interacting with some of my colleagues. A question popped up, and then guys were like, hey, what if there are no free versions for AI and the price has been raised high that only a few people can be able to purchase? Now that one leaves us with no option, because all our lives we have been vibe coding. So it's good for you to learn the basics. Yeah, you can utilize AI to understand. Be like, okay, as a basic beginner, break it down for me what I should cover. So by doing that, you're able to understand some of the basic things, because in everything, the foundation is one of the core elements. So when you understand, when you lay your foundation properly, AI is just coming to add on to your work. It's just to speed up your work. So what I can say is, understand the basics, understand the fundamental. Let it be let it plan your study, let it plan your journey, your roadmap. So you just use it, read a number of documentations, and some people will jump straight away to YouTube, but understand what you want, understand the basics, read, and then from there, YouTube will go and add, and AI adds on, so that it's easier. Because you might develop something, but debugging takes like a whole week. It's easier to code with AI, but the bugs that will be inside, it will take you a number of days. Then you understanding it fast, and then AI just wraps it up for you. I hope I've answered your question.
All right. Thank you very much, Emmanuel. And I think we are coming to the end of our session. A full hour, I think, is yet to, for those who joined on time, we are already at the top of the hour, but I want to mention that Joan Martha has, one of our kind facilitators today, has already shared some of the frameworks or languages or roles that you can become. as a software engineer, developer, programmer, application developer, product engineer, front-end wise. For those who are asking, do I become a front-end engineer or a back-end engineer or both? You really have to choose for starters to just reduce the scope of what you can be able to do. Start with front end if you can, start with back end if you can, then eventually you can become a full stack. So front end, we have front end engineers, front end developers, UI UX designers or engineers, web developers. I think Musa talked about website designers, web systems developers. I think those are the roles. React developer, Angular developer, Vue developer. Those are also different, I think, frameworks that are in the front end. Then back end, where we talk about, of course, backend engineers, developers, API engineers, server-side developers. Then in terms of languages, Python developer, Java developer, Node.js, and so on and so forth. And then for those who are talking about full stack, a full stack engineer is one who knows both sides, back end and front end, and they're able to play with all sides of the development process. So it combines both. So there is a full stack engineer and a full stack developer. And then we have mobile development, those ones who develop mobile applications. And then DevOps, development and operations all together. Site reliability engineers, platform engineers, infrastructure engineers, build release engineers, automation engineers, and then there is cloud. So there is a lot, and I think for today we've come to the end of our session. We are very, very honored and privileged to have had Martha, Emmanuel, Derek, and Musa taking us through today's session. And we hope that this becomes the foundation above which you can start pursuing your career. As well as if you do not have any ways to kickstart your career, TechBuzz Hub is always available to provide you a platform for kickstarting. We have a program that was presented to us all, the Graduate Professionals Apprenticeship Program, whereas it doesn't directly take people who are completely fresh into the development process, but at least if you have any questions, we can always provide you feedback. We can connect you to the people that spoke to you today and maybe help you understand which careers to pursue in that area of software engineering. But that said and done, I want to conclude by saying that you've been very, very an awesome audience. We believe that you've learned so much, very interesting questions you shared. As I conclude, I invite each and every one of you who is already into the development space. TechBuzz Hub runs a program called Graduate Professionals Apprenticeship Program that provides you 2 years of experience in 3 months. Doesn't that sound interesting to hear? Imagine you've just finished your career, but you're wondering where to start. You don't even know how to transition from the engineering from school or the development from school and putting it to work to solve problems in the workplace. TechBuzz Hub provides an opportunity for that by combining learning, support, and real work experiences or tasks which allow you to learn, and within a period of 3 months you are able to at least do some tasks, some jobs, or some roles for clients. It's always a learning journey. Not that Rome was built in one day, so at least you need a place to begin from. So with that said and done, allow me once again request our speakers to share their parting shots, and then we can call it a day. I will invite Martha to share her parting shots, and then Emmanuel, and lastly, Derek. That said and done, thank you, and over to you, Martha.
Yes, thanks. Thank you everyone for coming. It's been a really interesting presentation. You've been a really good audience. I hope we've learned a lot, and I hope we can connect more and grow together in this field that we all like. So yeah, thank you so much. Have a great day.
Yeah, thank you everyone for being on time, and it has been a great journey. And I can say it's good to join the team. I joined software engineering. It's really a good path to go, because we are not just engineers, but we are problem solvers. Because as a software engineer, you're solving a specific problem. Thank you, each and everyone. Have a good day.
Thank you everyone for tuning in. I remain Ajuka Derek Richard, and I would like to encourage everyone to stay curious and continue innovating. Thank you.
All right. From Tech Buzz Hub, we say thank you and have a very wonderful afternoon and the rest of the month.